First off, can you take me through the hyperbola standard equations again?
Oops. X minus h squared minus y minus k squared. The a and the b can be under either variable, and it can also be y minus k squared minus x minus h squared. And again, that could be b squared. No, actually, excuse me. The a always goes under the, well, it depends on whether it's a, here, let me see if I can remember this. This is a horizontal hyperbola because you've got x squared minus y squared.
Okay.
The A is always measured along the major transverse axis. So A is that measurement right there. So it always goes under the X if it's a horizontal hyperbola. That's number one, is horizontal. Number two is vertical. It looks like this. And the major transverse axis is that. And now that's A. And
Okay.
so whenever you have y squared minus x squared, a squared has to go with the y. And whenever you have x squared minus y squared, the a squared, the a goes under the x.
So what is B in terms of the graph?
Okay. The way you construct, you know, I never have quite enough room here. Oh, great. That's just when I need my eraser stopped working. What's going on here? Working very slowly. All right. So here's how you construct a hyperbola. Let's say you know it's a horizontal hyperbola. In other words, we're going to graph the first one. The way you construct it is you draw an imaginary box. This is actually a rectangle, and it can be wider than high, or it can be higher than wide. You then draw the diagonal through that rectangle, and those diagonals represent the asymptotes for your hyperbola. In other words, the hyperbola approaches those, never quite touching them.
Okay.
And A is the distance from the center to the vertex.
Okay.
And B is that measurement. Now, there isn't anything located right there. So B doesn't really show up because everything I've drawn in dotted lines there doesn't show up when you graph the hyperbola. In other words, if I wanted to graph it, I would erase my rectangle and the diagonal. I don't need them anymore. They were used only for constructing the hyperbola.
Okay.
Okay? And if I had a vertical parabola, then my box, this would be A, and this would be B, because the hyperbola would look something like this.
Okay.
And one of the things they're going to ask you is for the equation of those diagonal asymptotes. Well, notice in the drawing on the right, what's the positive slope of that asymptote? It's rise over run, correct?
Correct.
That's B over A.
Oh, okay.
There's the equation of that asymptote. What's the equation of this asymptote?
Negative B over A?
Yeah. And because these go through the origin, there's nothing else. In other words, there's no y-intercept. If the center is not at the origin, the equation of the asymptotes gets a little more complicated.
Right.
Then the asymptotes don't go through the origin, and they're going to have a y-intercept, and it's a lot more complicated. Whether you need that or not, I don't know. I don't think we should spend part of our half hour going over it unless you actually have problems where they ask you for the equation of the asymptotes for a hyperbola that's not at the center. I can give you those equations. You probably have them already in your book, but
All the problems that I have tonight are about ellipses.
oh, okay.
We had a substitute on Monday, and
Uh-huh.
she tried to teach us this stuff,
Yeah.
and she wasn't even supposed to teach us this. So we started learning it, and then Monday night I talked to you about it, and
Okay.
you properly taught me all the equations. And so we just learned ellipses today, and we haven't done hyperbolas.
Well,
And I had a question that she would answer.
ellipses are actually quite similar. It's just there's a plus sign in both in front of the x and the y. That's the difference. The only difference. Well, there's one other difference. And that is the A is always bigger than the B, and the A goes with the major axis. In other words, if it's a vertical ellipse, then the A goes under the y, or the A squared goes under the y.
Right.
And one thing different between ellipses and hyperbolas is for an ellipse, A has to be bigger than B. For a hyperbola, that's not true. There can be any relationship between A and B that you want. All right, specifically, what do you got?
This first one is find the vertices and foci. Graph each equation. Yeah, and then just graph the equation.
Okay.
So it's x squared over 25 plus y squared over 4 equals 1.
That I find it very helpful to first determine whether it's a horizontal or vertical. That makes all the difference in the world. What is this?
Horizontal.
Okay, so where's its center?
The origin.
Okay,
So
so it's going to look something like this. Is this measurement A or B? Where I'm pointing. Measurement from there to there.
A.
Okay. So what is A?
5.
What is B?
2.
So there's our graph, only we need the foci. So we also need those 2 points. And that's
Right.
measured from the center also. So what's the equation that relates A, B, and C? C is the measure to the foci.
C equals the square root of a squared plus b squared
Minus.
minus. Okay.
For ellipses. For hyperbolas, you got it right.
Okay.
Now, the biggest difference is, notice for an ellipse, A has to be bigger than B, otherwise you'll be taking the square root of a negative number.
Right.
For a hyperbola, it doesn't matter if A is bigger than B or not.
Right. Okay. That
Okay?
makes sense.
That's one way to kind of keep track of the difference. If
Yeah.
you know that ellipses, A has to be bigger than B, then you know it's going to be A squared minus B squared.
Okay.
So what is C equal to with our equation? Let's erase them. Let's see if my big eraser works. My medium eraser works a little bit better. I probably have to reboot my computer or something. I'm not sure. But okay, so what is C here?
4.5 or 4.6. Yeah.
You know, I don't like decimals when dealing with these, nor do your teachers.
Okay.
Give it to me in radical form.
Okay. Do you know how I would do that on the Nspire? How to switch the answer?
Well, you don't need a calculator to do this. A squared is 25, B squared is 4. That's the square root of 21. That's what C is.
Oh, okay. Gotcha.
And,
Sorry, I trying to find fraction.
well, decimals are merely hurting you here. If you give a decimal answer for that, you're given an approximation. If you
Right.
want the exact distance, you got to write it square root of 21.
Okay.
And that's why they leave everything in radical format, because they want exact precision. Mathematics is about precision. It's not about rounding off to something.
Right.
Okay, so my vertices are where? And your vertices are these two.
Right.
They apparently only, I don't know, do they want the minor vertices also? Probably. What's the coordinate on that vertice?
5, 0.
That one's 0, 2. And that one's minus 5, 0. And this one is 0, minus 2. Now the foci. What are the coordinates of my x point there? This point right there.
0, root 21.
That's the way you want to write it.
Okay.
Even if the origin's not at the center, you end up with, sometimes you get answers like this. That's the x coordinate. That's the y coordinate. So when you see answers like this, that's proper. That's the way they should be written.
Okay.
In other words, when you are combining a rational number with an irrational number, then you have to write it as 2 terms. There's no way to write that as 1 term without converting to a decimal. Okay? So don't be worried about giving x coordinates with 2 terms in them, like that. That's the proper way to do it. In this problem, that's not really a factor because our center is at 0, and so C is just plus 0, comma, I wrote that wrong. It's Not 0, comma 21. What is it?
Oh, it's root 21 comma 0.
Yeah. And this one's minus root 21, comma 0. Always a good idea to check those afterwards because it's really easy to make that mistake. I didn't catch it even when you told it to me the first time. All right.
Okay.
Missing there? No, they didn't ask for the center, but typically with an ellipse there are 7 key points. There is center, there are the 4 vertices, and there are the 2 foci. And usually they want all 7 points. And certainly to graph it, you kind of have to put all 7 points in.
Right.
What else you got?
4y squared plus x squared equals 8.
Okay. What's the first step here? At this point, I can't even tell whether it's horizontal or vertical.
Right.
What do I got to do?
You divide by 8.
Okay, so that gives us y squared divided by 2 plus x squared divided by 8 equals 1. Now I can tell whether it's horizontal or vertical. What is it?
Vertical. Horizontal, sorry.
Horizontal, correct, because the bigger number is under the x term. And a is always bigger than b, so 8 is a squared, 2 is b squared.
Right.
Which means a is the square root of 8, or 2 root 2, and b is just root 2. And what are they asking for here? The same thing, the vertices and the foci?
Yes.
Now let's figure out c. Tell me what c is.
Square root of 6.
Okay, good. Very good. Did that pretty fast. Okay, so let's start to draw our graph. Again, we're at the center. Makes these quite a bit easier.
Yeah.
Let's figure out those 4 points. Coordinates on them. How about the one on the right?
2 root 2 comma 0.
Making this negative 2 root 2 comma 0. And this one is 0 comma root 2, and this one is 0 comma negative root 2. Now what's the coordinates on the foci?
Root 6 comma 0 and negative root 6 comma 0.
Okay, these are pretty easy when they're at the origin. Do you have any that are not at the origin? And
Yes.
what you can tell is if your equation has a y or an x in it.
Right.
Then it's not at the origin because we have to complete the square and we end up with an h and a k that are not both 0.
Yes.
Those tend to be slightly more difficult. We only have 12 minutes. Unfortunately, I have an 8:30 that I'm going to have to go to. But,
Okay.
so maybe give me a little tougher one.
Yeah, this one is x squared plus 4x plus 4y squared minus 8y plus 4 equals 0.
Okay, first thing I'm going to do is move that 4 over. You see why?
Yes.
because I'm trying to manipulate this equation into the general equation. Okay? Now,
Right.
for me to turn this into an x minus h squared, I've got to complete the square. Okay, so I'm putting parentheses around it, leaving room to complete the square. Over here, I'm going to do the same thing, but over here I can't complete the square until I factor out the 4.
Right.
So this turns into x squared plus 4x plus room to complete the square. Factor out the 4, what do you get?
4 times y squared minus 8y.
Not 8.
Oh, sorry, 2y.
Remember the secret to always not change the equation.
Right.
In other words, every time you go from one row to another, check to make sure you haven't changed it.
Right.
It's not that hard to check. I can see that's exactly the same. But over here, I got to distribute that 4 back to make sure I get 4y squared minus 8y. Now complete the square with the x's.
X plus 2 squared.
You take half of this coefficient and square it.
Oh, I'm sorry. I jumped the shark. Plus 4. Yeah.
You can't really jump the shark, because if you do, you don't end up with the right number over here. In other words, if I immediately turn that into x plus 2 squared, I don't know how much to balance it out with.
Right.
Well, when I write the 4 in there, I know I got to add 4 over there. Complete the square with the y's.
4 times the quantity of y minus 1
No, just
squared.
complete the square. Don't try to put it into the linear term yet. You're getting ahead of yourself.
I'm sorry.
Okay.
Plus.
Plus 1, right?
Yeah.
How do I balance that on the other side?
Add 4.
Okay. In other words, that's why I can't skip steps.
Right.
Because I have to know what to add to the other side to balance that. Now I can write it as a linear term. X plus 2 squared plus 4 times y minus 1 squared, and it's equal to 4. Right? If I add those 3 numbers together, I get 4.
Yes.
Now what?
Divide by 4.
Okay, so now I got x plus 2 squared divided by 4 plus y minus 1 squared, not divided. I'll put 1 under there, equals 1. Now, since this is an ellipse, is it a horizontal or vertical? And this is really the first point where I know. Because I guess if I thought about it, I could figure out whether it was horizontal or vertical from that. But notice it's a little different. A is 4, or a squared is 4, whereas I'd have a hard time telling that from that equation.
Right. It's horizontal.
Okay. Hold on, let me need more room to graph this. Let me move it down. And we're just going to find all 7 points. Where's the center?
Negative 2 comma 1.
What's the something like that. I'll draw a very good ellipse, but I think you know what I'm trying to do. What's this vertex right there?
0 comma 1.
This vertex over here?
Negative 4 comma 1.
This minor vertex right there.
-2, comma 2.
And then this vertex down here.
-2, 0.
And the foci. What is C equal to?
√3.
A squared minus B squared. Right?
How did...
No, you're right. My mistake. My mistake. I was squaring these. They're already squared. In other words,
Right.
you know where I made my mistake was not listing A and B. If you list
Right.
A and B, you won't make the mistake I just made. A is 2, B is 1. Now I can plug these numbers into here and get √3. So what is that coordinate?
-√3.
Actually, -2 plus √3 is the x coordinate.
Oh, right, okay.
Okay, comma 1. That's the y coordinate. And again, that's the correct way to write it. What's that?
Okay. -2 minus √3.
Okay,
Comma 1.
comma 1. And that's everything. Well, 7 points.
Okay.
Okay. Yeah, this is actually a pretty easy mistake to make. Did I make? Or
Yeah.
that I made. And that's thinking that that was A instead of A squared. Okay. Did I give you, we only have 4 minutes. Let me just give you, I might have already done this for you, but maybe I did. What if I had this? What's A, B, and C? Or what's A and B? Notice that I can't divide everything by 1 and end up with anything in the denominator.
Right.
Or I can't divide everything by the number on the right side. Most of the time you can. Usually when you divide by the number that makes that 1, you end up with numbers in your denominator. But
Right.
now I have to figure out what the denominator actually is.
They're both 1.
Well, they're 1 at the moment, but
Do you complete the square?
no. You need the denominator, you need the numerator to have a 1, is what you need. So what does the denominator have to be here for this coefficient to be 1?
Four.
Is that the same as what I got?
No.
No, it isn't. That's what you have to ask yourself. That's not the same.
Is it 1/4?
Yeah. In other words, the way I get that is by dividing top and bottom by 4. Well, when I divide the top by 4, I get 1. But when I divide the bottom by 4, I get 1/4. Same with the 9. That becomes y squared over 1/9.
And so doing that to separate terms within the equation doesn't alter the value?
No, you can take any fraction and multiply it by the number 1 without changing it. So when I divided the top and bottom by 4, is all I did was divide the expression by the number 1. You can always do that. And sometimes your number 1 is fraction, sometimes it's a complex number, sometimes it's all kinds of things. But know that when you're dealing, there's two things you have to really separate in your mind. One is when you have an equation, you can do anything you want to one side of it as long as you do it to the other. And I mean anything. You can square it, square root it, take the log of it, take the derivative, take the integral, anything you want, as long as you do it to both sides.
Okay.
But if I have a fraction like this, 3 plus 2i, and I'm dividing it by 4 minus 5i, well, I don't know how to do that division, but I do know how to multiply that fraction by the number 1. Only the number 1 is going to be 4 plus 5i divided by 4 plus 5i. So all I'm doing is multiplying that fraction by the number 1, right?
Right.
And what you accomplish by doing that is you turn the bottom into a real number and you don't have a complex denominator. Having a complex denominator is a bit like having an irrational denominator. In other words, if I have 1 over square root of 2, I got to rationalize that denominator. I can do it by multiplying this fraction by the number 1. My number 1 is going to be square root of 2 over square root of 2, giving me square root of 2 over 2. So you notice that whenever I do this process, all I'm doing is multiplying or dividing the fraction by the number 1. It's just what does it made up of? In this case, it's square root of 2 over square root of 2. In this case, it's 4 plus 5i over 4 plus 5i. In our case, I was merely dividing the top by 4 and the bottom by 4.
Right.
The mistake you made putting a 4 there, very, very common. 90% of the people are going to do that because you don't think of that 1 as being there. In other words, when I say divide the top and bottom by 4, most people turn that into x squared over 4. They do, even though those are not the same expressions. I've changed it when I do it this way. William, I got to run. I got an 8:30 waiting on me.
Okay. Thank you very much, Mr. Kelly.
You're welcome. I'll talk to you. I think you got some more either tomorrow or Friday, but I'll talk to you then.
Okay, great. Thank you.
All right. Bye-bye.